Let's start permutation and combination. So first of all, what is permutation? So permutation is all related to the act of permuting or rearranging objects or values. Okay, it just means rearranging. And what about combination? So combination is a way of selecting several things out of larger group. Okay, where unlike permutations, order does not matter. Here, order does not matter. All right. Permutation is all about rearranging, and in combination, order does not matter. In which order you are arranging the terms, okay? You'll understand that, okay, when we'll discuss the questions, all right? So, first, let's go through the basics and then we can discuss the questions. Let's just first go through the theory, all right? Since it's the revision session, or you can say crash course. Now, this is called factorial. What it is called? These are the signs for factorial, okay? Right, so n factorial means n, n minus 1, n minus 2, up to 3, 2, and 1, okay? Or n factorial is equal to n minus 1, n minus 2, n minus 3, n minus 4, n minus 99, n minus something something, and up to 1, okay? Not 0. 0 factorial means 1, okay? That's why it is only up to 1, alright? So always remember 0 factorial means 1. Now factorials of only natural numbers are defined, okay? So you can only write it for natural numbers, right? N factorial is equal to n minus 1, n minus 2, etc. Right? So n factorial is defined only for natural numbers. Means n must be greater than or equal to 0, right? So n factorial is not defined for n less than 0, okay? It is not defined. Right? Now, what do you mean by NCR? Okay, so NCR is 1 when n is equal to r, alright? For example, 1C1 is 0, sorry, 1, 2C2 is 1, 3C3 is 1, that way, okay? So what is this C? So combinations represented by NCR, okay, can be defined as the number of ways, can be defined as number of ways in which r things at a time can be selected from amongst n things, okay?
Okay, sir.
available for selection. Again, combinations, which is represented by NCR, can be defined as number of ways in which R things at a time can be selected among N things. All right.
Yes.
So please, the keyword here is selected. Okay.
Okay, sir.
The keyword here is selected. Please understand here that the order in which the R things are selected has no importance in the counting of combinations. Okay. The order
Oh my God, it's so loud.
in which the R things are selected has no importance in the counting of combinations. So NCR is equal to number of combinations. That means number of selections, right?
Yes, sir.
Number of combinations or selections of n things taken are at a time. All right. So you can write this NCR. This is the main formula. Okay. NCR is equal to n factorial divided by r factorial multiplied by n minus r factorial. Okay. Very important formula. All right. Where n can be greater than or equal to r. Okay.
Yes, sir.
So let's discuss some typical situations where selection combination is used. Where selection or combination is used. For example, first, selection of people for a team, a party, a job, an office, and so on, right?
Yes.
For selection of a cricket team of 11 from 16 members, right?
Yes, sir.
Second, selection of selection of a set of objects, okay? Like letters, hats, shirts from amongst another larger set available for selection amongst another larger set available for selection. So, in other words, any selection in which the order of selection holds no importance is counted by using combination. Let me write that again. In other words, any selection in which the order of selection holds no importance is counted by using combinations. Okay, order of
Yes, sir.
selection holds no importance here. Okay,
Okay,
it
sir.
doesn't matter in which manner you are selecting the things. Okay,
Okay, sir.
so this was about combination, right? Now let's understand permutation. Okay,
Yes, sir.
so permutations is represented by NPR. Okay, and it can be defined as the number of ways in which R things at a time can be selected and arranged at a time from amongst N things. Okay, from
Okay,
N
sir.
things you are selecting R things. Okay,
Yes,
N things you are selecting R things. So the keyword here is arrangement. Okay, so let me write it fully.
mm,
NPR can be defined as the number of ways in which R things at a time can be selected and arranged at a time amongst N things. So here the keyword is arranged. Okay, it
sir.
can be selected, but it should be arranged. Okay, in a manner. So the keyword here is arrangement. Hence, please understand here that the order in which the R things are arranged has critical importance in the counting of permutation. Okay,
Okay.
let me write it down. That the order in which R things are arranged has critical importance in the counting of what permutations. Okay,
Permutation.
So here NPR stands for number of permutations. Okay, means arrangement. Okay, not a selection. It's an arrangement. Okay, of n things taken
Yes.
at r time. Okay, so you can write NPR as n factorial divided by n minus r factorial. That's the difference. Okay, in NCR, what was the formula? It was n factorial divided by r
Divided by
factorial
n
multiplied by
factorial
n
plus
minus.
n minus r factorial.
Here in permutation, we are excluding this r factorial. Okay.
Yes.
So, what are the typical situations where order or selection permutation are used? So, making words and numbers from a set of available letters and digit respectively. Okay.
Okay.
Filing post with people, selection of batting order of a cricket team of 11 from 16 members, putting a distinct object or people in a distinct places. For example, making people sit, putting letters in envelopes, finishing order in a horse race, etc. Okay,
Mm. Okay, sir.
where arrangement matters, right?
Yes, sir.
So you'll understand this thing when we'll discuss the examples. Okay.
Okay.
Now, what's the relationship between permutation and combination? So, when we look at the formula for permutation and combination and compare the two formulas, okay, and NCR was n factorial divided by r factorial multiplied by n minus r factorial. So, this n factorial divided by n minus r factorial is nothing but our NPR, right?
Yes.
So, you can write NCR is equal to NPR divided by r factorial. Yes or no?
Yes, sir.
Right?
Yes, sir.
There is another formula as well. You can write it this way. From here, you can write NPR is equal to, you can take this side, right? It will become r factorial multiplied by NCR. Yes or no?
Yes, sir.
Now, let me write some important results and then we'll go towards the examples. Okay.
Okay, sir.
So, number of permutations or arrangement of n different things taken all at a time is n factorial. Okay.
Okay.
Number of permutations of n different things taken all at a time is given by n factorial. Okay.
Yes, sir.
Second, number of permutation of n things out of which, let's say, p1 are alike and are of one type. Let me write this down. Number of permutations of n things, out of which P1 are alike and are of one type, and P2 are alike and are of a second type. Okay, so P2 is basically second type, and P3 are alike and are of third type. Okay,
Okay.
and the rest all are different. Okay, different. Then you can write it as n factorial divided by P1 factorial, P2 factorial, P3 factorial. Okay,
Okay, sir.
good. Now let's
Yes.
take few questions. Okay, examples.
Okay.
Question 1. Again, I'm discussing this question from standard reference books. Okay,
Okay, sir.
the number of words formed with the letter of with the letters of the word Allahabad. The number of words formed with the letters of the word Allahabad. All right. So first of all, how many letters are there in this word? Total number of letters is how much?
Nine. Nine, sir.
9. Of which A occurs how many times? 4 times, right?
Yes.
L occurs how many times? Twice. And the rest are different, right?
Yes, sir.
All right. So total number of words formed would be, it would be simply 9 factorial. Remember that formula? We just wrote it down. See here, n factorial divided by p1 factorial, p2 factorial, p3 factorial, right? So
Yes.
using that here, it would be 9 factorial because number of letters are 9 divided by p1 factorial. That means a letter occurs how many times? 4 times, right?
Good time. Yes.
So 4 factorial. Another letter that is L that occurs 2 times, right? So 2 factorial. And the rest are different. So just 1 factorial, okay? Good.
Yes, yes, sir.
So this would be its answer. What about
So you
repetition?
don't have to calculate it.
Yeah, we need to calculate it. Okay, we can
Okay.
calculate it. 9 factorial means
Yes,
9 multiplied by 8
yes,
multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial, right? Why I
yes,
only wrote down up to 4 factorial? because in the denominator there is 4 factorial, right? So we can cancel it out. 2 factorial means only 2, okay? Because 2 factorial means 2 multiplied by 1, that is 2, okay? And 1 factorial means 1, okay? So here 2 4s are 8, right? So just write down the answer. So I'm not writing it down, okay?
Okay.
Okay. Another important thing that I forgot to tell you. So please write this down, that number of permutations of n different things taken are at a time. When repetition is allowed, okay?
Yes.
That means basically n multiplied by n multiplied by n multiplied by n and so on, right?
Yes,
R
sir.
times. Yes or no?
Yes, sir.
That just basically means n raised to r, okay? Good?
Yes, sir.
Okay, next question. In how many ways can 4 rings be worn in the index, ring finger, and middle finger if there is no restriction of the number of rings to be worn on any finger. Again, read the question. In how many ways can 4 rings be worn in the index, ring finger, and middle finger if there is no restriction of the number of rings to be worn on any finger? Okay, you can wear it simultaneously as well. Okay, there are 3 fingers,
Oh,
right? Index, ring finger, and middle finger. Okay, and how many rings? How many ways can, I mean, how many rings are there? 4 rings, right?
four. Yes, sir.
So if there is no restriction of the number of rings to be worn on any finger, that means you in one finger you can wear all of the rings, right?
Yes, sir.
So here each of 4 rings could be worn in 3 ways, either on the index, ring, or middle finger, right?
Yes, sir.
So 4 rings could be worn, right? In how many ways? So we just wrote it down, right? For repetition, see here, number of permutation of n different things taken are at a time when the repetition is allowed. So you can write n multiplied by n multiplied by n. How many times? R times. That means basically n raised to r, right? So here you can write 3 multiplied by 3 multiplied by 3 multiplied by 3, right? Because
Yes, sir.
r things are there. R things means 4 things.
Four.
That means 3 raised to 4v. That is our answer. Understood?
Yes, sir.
Okay. Another property or another rule. Number of selections of r things out of n identical things. Okay. Number of selections of r things out of n identical things is equal to 1. Okay. So if you want to select, let's say, 3 balls, okay. Let's say there is a
Yes.
bucket full of yellow balls, okay. And if you want to select any 3 balls, okay, so you can select any 3 balls, right?
Yes, sir.
Yes or no? Because all of them are identical.
Yes, sir.
So how many number of selection is required? Only one time, right? You can
Yes,
just
sir.
grab the balls, right, without
Yes, sir.
even looking at it, because all the balls are yellow. So that's why number of
Yes.
selections of r things out of n identical things. Okay, there is this word identical is 1. Okay, we can actually
Yes,
prove
sir.
them. Okay, for example, if you look at this question, in how many ways 5 marbles can be chosen out of 100 identical marbles? So here its answer is 1, right?
Yes, sir.
That's it. The condition is the things that you are looking at, or you are trying to select, right? They should be identical, all of them. Okay, then and
Yes.
then only you can get this result. Okay,
Yes.
now another very important point: total number of selections of 0 or more things out of k identical things. Total number of selections of 0 or more things out of k identical things. Things are identical, but how many things are there? K identical things. Okay, so total number of selections of 0 or more things out of k identical things is equal to k plus 1. Okay, all right.
Yes, sir.
So this includes the case when 0 articles are selected. Okay, we'll discuss that example as well, but not right now. Another point: total. Number of selections of zero or more things out of n different things can be written as, this is the same thing but we are writing in terms of combination. Okay, total number of selections of one or more things, total number of selections of zero or more things. Okay, out of air, out of n different, can be written as nc0 plus nc1 plus nc2 plus up to ncn. Okay, that is equal to 2 raised to n. This is a very important result. Okay, total number of selections of zero or more things out of n different things. Okay, here they are not identical. Okay, here they are different things. So for example, if we want to select three things, three different things. Okay, all right, we'll take an example. Okay, so first one is for identical things. Okay, and the second line or second point is for different things. Okay, all right.
Yes, sir.
Okay, now there are many things that we can discuss. Okay,
Yes, sir.
so yeah, let's discuss third point. Third point is this, that the number of selections of one or more things out of n different things. The number of selection of one or more things out of n different things can be written as nc1 plus nc2 plus up to ncn, and that can be written as 2 raised to n minus 1. Okay.
Okay, sir.
Now what about division? If you want to divide something, so number of ways of dividing m plus n different things in two groups containing m and n things respectively. So that can be written as m plus n cn multiplied by m cm is equal to m plus n factorial divided by m factorial and n factorial. Okay.
Okay, sir.
Number of ways of dividing m plus n different things into groups containing m and n things respectively can be written as m plus n factorial divided by m factorial and n factorial. Okay.
Okay, sir.
So for example, number of ways of dividing two and different things into groups containing n things. So here it would be simply 2n factorial divided by n factorial and again n factorial multiplied by 2 factorial. Okay.
Yes, sir.
Now you can write ncr plus ncr minus 1 as n plus 1 cr. Okay.
Yes, sir.
These are the addition of combination. Now if ncx is equal to ncy, then you can say x is equal to y. Okay.
Yes, sir.
You getting my point?
Yes, sir.
All right. So let me ask you some questions. But before that, let me discuss important result. Okay.
Yes,
Number of ways of arranging n people on a circular track, or you can say for circular arrangement, the value is n minus 1 factorial. Okay.
okay, sir.
Second point, when a clockwise and anti-clockwise observation are not different than number of circular arrangement of n different things would be n minus 1 factorial divided by 2. Okay. When clockwise and anti-clockwise observation are not different, then number of circular arrangement of n different things can be written as n minus 1 factorial divided by 2. Okay.
Okay, sir.
For example, there is this circular track, right? Let's say we arrange these people. So if you look from here, they all look same, and if you look from here, they all look same, right? It doesn't
Yes,
matter if you are arranging them in this direction or in this direction, right? In that
yes,
case, the arrangement can be it will be equal to n minus 1 factorial divided by 2. Are you getting my point?
yes, sir.
So this is the number of arrangement. So let's take an example. It's a very famous example. Okay.
Okay,
number of squares and rectangles in the following figure. So in this figure, you need to find total number of squares, sorry, yeah, and rectangles. Can you do that? So how many squares are there? 1, 2, 3, 4,
Three,
5,
four,
6,
five,
7,
six,
8,
seven,
9.
eight, nine, 9.
Then this big one, that is 10, right?
Yes, sir.
Then this one, 11, right? Then this one, 12. Then this 30, 13, and this one is 14, right?
Yes,
So here you can write a number of squares as 1 square plus 2 square plus 3 square, okay? That will be equal to 14, alright? And
yes,
number
sir.
of rectangles can be written as 1 cube plus 2 cube plus 3 cube, okay? Is equal to 36 for rectangle, okay? So how many rectangle are there? 36. So this is a 3 by 3 cube, right? So square, yes or no? So for a 3 by 3 square, you can write, if you want to find the square, just write it this way: 1 square plus 2 square plus 3. Your answer is 40. And if you want to find a rectangle, number of rectangles, so for a 3 by 3 square, it would be 1 cube plus 2 cube plus 3. Now let's say they have given you 4 by 4 cube, okay? So in that case, number of squares would be 1 square plus 2 square plus 3 square plus 4 square, right? And number of rectangles would be 1 cube plus 2 cube plus 3 cube plus 4 cube. Are you getting my point?
Yes, sir.
Good.
Yes, sir.
Next question. In how many ways three prices three prices can be given away to 7 boys when each boy is eligible for any of the prizes? Is eligible for any of the prizes. This is the question. Read that again. In how many ways three prizes can be given to 7 boys? How many prizes are there? Three.
7.
And number
3,
of
sir.
boys are
7.
7, right?
Yes, sir.
Boys are 7. Okay. So first prize and second prize can be given to same boy. Yes or no?
Yes, sir.
because each boy is eligible for any of the prizes, right? There are three
Yes, sir.
prizes, right?
Yes, sir.
So this is the first way. Second way would be first boy and then second boy gets the same prize, right?
Yes,
So two prizes can be given to the same boy, but two boys cannot get the same prize, right?
yes, sir.
Therefore, we must start with the prize, right? So each
Yes,
of the three prizes can be given away to any one of the seven boys in seven ways. Yes or no?
yes, sir.
So remember we had this formula n factorial divided by p1 factorial, p2 factorial, p3 factorial. Yes or no?
Yes,
So
sir.
that way here it would be no, but here the you can also take a repetition, right?
Yes, sir.
So for that we had this formula n multiplied by n is equal to n raised to r. Remember? So
Yes, sir.
therefore the required number here would be 7 multiplied by 7 multiplied by 7. That gives us 7 raised to. That's the answer. Now let's take the last question. The letters of the word figment. The letters of the word figment are to be arranged in the manner such that vowels at first and last position. How many words can be formed? The letters of the word figment are to be arranged in the manner such that vowels at first and last position. Okay, so we need to take vowels at first position and last position. So how many words can be formed this way? So first place can be taken by I and last by E, right? Yes or
Yes,
no?
sir. Yes, sir.
Or vice versa, right?
Yes,
So
sir.
remaining five positions, first, second, third, fourth, and five. Remaining five positions can be filled by five letters in five ways, right? That means
Yes, sir.
five factorial ways. So total words formed would be five factorial multiplied by these two, right?
Yes,
That
sir.
would be 5 multiplied by 4, 3, 2, 1 multiplied by 2. That gives us 240, okay? And that would be your answer. Understood?
Yes, sir.
Good?